In this video, we're talking about another type of problem that can be solved using the immediate value theorem. It might look different at the outset, but it really comes down to the exact same methods we talked about in the last video. The problem of this sort is finding solutions to equations. So the idea is you'll be given something like, show that there is a solution to g of x equals h of x on some interval. I'm being really vague here, but we'll see it in the actual example what it looks like and see where it goes from there. But we're trying to show that there is a solution to a certain equation like this on some interval. And really what this comes down to is I can just throw the h of x onto the other side and get that this is the same thing as g of x minus h of x equals 0. But this problem is something we know how to do already. If I'm looking for a 0 of a function, that's easy. That is the IVT problem we did last time. And because these two are equivalent, the fact that finding this 0 is equivalent to finding this equality, I can just solve this other problem and then use that point to give me my solution to the first problem. That's all we're going to do here. All we're going to do is move one function to the other side and then solve by the previous method. It's easy as that. So let's look at an example. Show that there is a value of x between 0 and 4 so that cosine of 2x minus sine of 3x equals x squared. So let's take the x squared and throw it to the other side of the equation and call that resulting function our f of x. So we're going to have cosine of 2x minus sine of 3x minus x squared equals 0, and we'll call this guy f of x. What do I need to apply the IVT results I had last time? Well, I need continuity, and I need a positive value and a negative value. So let's give it a shot. Continuity. We're good here. F is continuous because sine, cosine, and x squared are all continuous. So we're good there. We know our function is continuous. We can just use it and be all set on that front. Now let's check some values. We're told to look between 0 and 4. So what is f of 0? Well, f of 0 is going to be cosine of 2 times 0 is 0, minus sine of 3 times 0 is 0, minus x squared, which is 0 squared. Well, this is cosine of 0 is 1, sine of 0 is 0, and 0 squared is 0. That's 1, which is positive. Fantastic. Now let's check 4. F of 4 is going to be cosine of 2 times 4 minus sine of 3 times 4 minus 4 squared, which is cosine of 8 minus sine of 12 minus 16. This might look confusing at first and hard to solve, but the point is, all I want is that it's negative. Well, cosine can't be bigger than 1. It oscillates back and forth between minus 1 and 1. So that can't be bigger than 1, and that can't be bigger than 1. Or I guess less than minus 1 since I will have a negative sign in front of it. So this 16 is just going to dominate everything, right? Cosine of 8 is no more than 1. Sine of 12 is no less than minus 1. So this has to be less than minus 14. In particular, we know it's less than 0. So I have f being continuous. I have 0 as giving a positive value, and 4 giving a negative value. Therefore, by IVT, there is a point between 0 and 4 where f of c is 0, or cosine of 2c minus sine of 3c equals c squared, by the fact that we had f just for moving that over the other side. So there's our answer there as well. But that's the idea. Move to the other side, and then just take that as my function f. I'm now looking for a 0 of this function f. So I check continuity, positive endpoint, negative endpoint, and I get the answer I'm looking for. There's also a second way you can think about these sorts of problems, And that's in terms of the graphs crossing. And the idea is sort of as follows. If I have axes and I have A and B, how can I force two graphs to cross assuming they're both continuous? Well, if one starts higher on one side and ends up lower on the other side, that's going to force the two things to cross. So if one graph starts up here, ends up down here, and the other one starts down here and ends up here, there is no way I can draw a green line from green to green and a purple line from purple to purple without them crossing. Try as I may, assuming they're both continuous and they're functions, they're going to have to cross somewhere. So you could phrase these problems in terms of solving g of x equals h of x by finding a point where g is bigger and a second point where h is bigger. Right, we could have done this with our last problem as well. At 0, the cosine 1 is bigger because it's equal to 1, and at 16 or at 4, the x squared is bigger because it's 16, a lot bigger than cosine and sine. So if you do it that way, then there is a point in between where they are equal. So you can use either of these methods to figure it out. I would encourage just going back to the first one because that gets you one method to solve all these types of problems. It's always throw it all to one side and then solve for a 0. If you get that method down, you should be in good shape for all these problems that you see. All right, that is it for this one. And in the next video, we'll talk about the bisection method, which gives us a different way of trying to actually locate these points that we want, as opposed to just saying they're in there somewhere. So we'll do that in the next video.